All right,
Cheers,
here we go.
Thank you so much, Mary. I really like it.
All right, so we're talking to somebody from Nector, and you are?
My name is Molly Romani. I'm Vice President of Business Development and Marketing.
Vice President, okay. And we're looking at a fuel cell.
Exactly.
A real honest-to-goodness fuel cell.
A real honest-to-goodness fuel cell, and not like some science fiction story in the future. Right, this is real. I am actually now...
How do I know it's real?
How do you know it's real?
Yeah.
Well, A, I'm telling you, and B, I've got my CTO here, so he'd tell me if it wasn't.
Oh, he'd vouch for you?
He'd vouch for me.
Okay.
Well, actually, so here it is.
This is it?
This is it. This is what we call a silicon power cell. It's a solid oxide fuel cell that we've imprinted and miniaturized and put it onto a silicon wafer.
Okay.
This device...
And why have you been able to do it where everyone else has failed?
Because we've solved two of the biggest problems that solid oxide fuel cells have, if you want to miniaturize it down. One is you've got to have an incredible insulation technology, and secondly, you have to basically understand the thermal coefficients of expansion.
Insulation because it gets hot?
Because it gets hot.
And what is your insulation technology?
I will tell you.
Don't say it's a secret.
It's not a secret.
Okay.
We have a technical paper that I'm going to give you that you can read in detail, but it's got thin-walled silicon nitride tubes that we've fundamentally been able to use to isolate the conductive and all of the different heat losses inside the fuel cell.
So it's a passive
absolutely
sort of a heat conductor or something, or shield, or insulator? Or?
Yeah. In fact, it's in there. In our biscuit, so you can read it.
So that's one. So the insulation was one thing. Or isolation of the heat. What's the second?
That was a big one. The second is the thermal coefficients of expansion that you have to match between different layers of the silicon and the fuel cell material, and we've been able to solve that as well too.
So you've tackled two big obstacles that other people have failed, and you've been able to make an affordable
fuel cell. $299 for the device, $10 for the cartridge. 2 weeks of power for $10.
So 2 weeks continuous power.
2 weeks. Well, the way to think about it is the device itself. Each cartridge holds 55,000 milliwatt hours.
55,000, as opposed to a AA battery that holds about 2,500.
Yeah, exactly, precisely. Just literally an order of magnitude over.
20 times more.
Exactly, 1.5 orders of magnitude more than your standard battery in a single cartridge.
And it's called Nector, and it's got all these USB adapters. And so it's like a little power pack, a fuel cell power pack. How long does it take to... So how do you recharge this fuel cell?
How do you recharge this, or how do you recharge
You recharge the fuel cell.
Oh, you don't really. Once the device has charged, once the energy inside the power cell has been depleted, you eject it. You put it in the recycling bin. You get another one for $10, and you pop it in there.
Okay. So I get 55,000 milliamp hours for $10.
Exactly.
And can't fuel cells be recharged?
Well, our device you can take and use on planes, and the only way we're able to get the approvals, and we want to approve is by ensuring that individuals don't recharge them because they'll be worried about that. But the whole point is, for $10, for 2 cups of coffee, would you get 2 weeks of power?
I don't know.
It's if you don't make it onerous to the individual, then we believe it's a great deal.
Okay, so it's it's the ultimate battery.
It is the ultimate battery.
Okay, very good. All right, thanks a lot.